Welcome to Prajim Technologies. I am Venkat and this is part 1 of Cloud Computing tutorial. In this video series, we'll understand what is cloud computing and the options we had before cloud computing came into existence. Along the way, we'll understand everything you need to know to build cloud-ready applications. Cloud computing is everywhere. It's a big shift from the traditional way businesses think about IT resources. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases. You're probably already using cloud computing right now, even if you don't realize it. For example, if you're using an online service like Gmail to send emails, edit documents using Google Docs, or stream music or films online, it's likely that cloud computing is making it all possible behind the scenes. Not all clouds are the same, and not one type of cloud computing is right for everyone. Several different models, types, and services have evolved to help offer the right solution for your IT needs. For example, financial services companies are using the cloud to power real-time fraud detection and prevention. Healthcare companies are using it to develop more personalized treatment for patients, and video game makers are using it to deliver online games to millions of players around the world. There are many cloud-related concepts like infrastructure as a service, platform as a service, software as a service, private cloud, public cloud, hybrid cloud, serverless computing, and many more concepts. Cloud computing is massive, so here is what we're going to do. We'll have two courses, Cloud Computing Tutorial for Beginners and Azure Tutorial for Beginners. In the market today, there are many cloud providers, that is, organizations that provide cloud computing services. For example, some of the main players are Microsoft, Amazon, Google, IBM, etc. So, in the first course, that is Cloud Computing Tutorial, we'll cover all the concepts and cloud-specific technical terms that are common across all these different cloud providers. So, it doesn't really matter which provider you want to go with. This course is for anyone who wants to learn and understand cloud computing in general. Azure is the cloud computing service from Microsoft. In our second course, that is Azure Tutorial for Beginners, we'll discuss everything you need to know to build, deploy, and scale applications using Azure. As you know, cloud computing is ever expanding and it is here to stay. It doesn't matter whether you're a software developer, quality engineer, business analyst, software architect, project manager, or head of development. This course is for anyone who wants to understand what cloud computing is and how it's changing the world of information technology. I will do my best to cover all the cloud-related concepts, but in the meantime, if you have a specific concept in mind that you want me to cover, please leave it as a comment on this video and I will surely discuss it in our upcoming videos in this series. Finally, your feedback is really important and means a lot. So if you have a few minutes, please let us know your thoughts and feedback on this course. I'm really excited and looking forward to take you through the journey of cloud computing, and I hope you are too. This is part 2 of Cloud Computing tutorial. In this video, we'll discuss the state of information technology before virtual machines came into existence. You name any business or industry, airlines, tourism, hotels, software, hardware, manufacturing. It is the applications that power and run these businesses. It's almost impossible for a business to withstand the pressure and competition and thereby sustain in the market without a reliant, performant, and a scalable application. So the fact is, it is the applications that power and run businesses. As far as an application for a business is concerned, there are two main aspects: designing and developing the business application itself, and then hosting this application on a server to make it available for business. So let's discuss what we used to do in the past prior to the technologies like virtual machines and containers came into existence. We'll discuss what virtual machines and containers are and the problems they solve in our next video. So, in the past, to host an application, a business needs to procure a physical server. But the question is, how big and fast the server has to be. it's not easy to speculate the demand for the application. So to be on the safe side, businesses procure a high-end server, which obviously costs a lot of money. Now, in addition to this initial capital expense, that is the cost of the physical server, we also have monthly recurring operating expenses like energy cost, for example, that is both for power and cooling. And we also have to hire workforce to maintain the server. Don't forget the operating system license. We have to pay for that as well. In many cases, only a fraction of the server capacity is used, which means obviously a lot of company money is wasted. So we have a physical server. On top of that, we install the operating system, and on top of that, we install our business application. At this point, we have our application up and running and users are able to use it. Now, let's say we're launching a new product or starting another line of business, and obviously this means we need another application. So we need to procure another physical server and another license for the operating system, and on top of that we install our second business application. Keep in mind, in addition to the cost of the second physical server, we also have recurring operating expenses. At this point, you might be wondering, can't we install this new application on our existing physical server, because the first application is only using a fraction of the server capacity anyway? Well, in most cases, we can't. This may be because this new application has different dependencies than the first application. Maybe it needs different version of the framework installed, or maybe it needs a different operating system altogether. Even worse, maybe both applications need access to the same resources or devices, which obviously results in resource conflicts. One way to solve this problem is to buy another physical server. So in the past, there's a one-to-one mapping between an application and a physical server. Every time we need a new business app, we end up buying a new physical server. And keep in mind, these applications are using only a fraction of the server capacity. What a waste of company money. You can see how quickly this can become unwieldy and very expensive for the organizations. This is the model we had until virtualization came into existence. In our next video, we'll discuss what virtual machines and containers are and the problems they solve. This is part 3 of cloud computing tutorial. In this video, we'll discuss what a virtual machine is and its use. We usually cannot install more than one application on a given physical server. We discussed the reasons for this in our previous video. Until virtual machines came into existence, we had a one-to-one mapping between a business application and the physical server upon which it is installed. For example, if there are 3 production apps, 3 physical servers are required. Every time a new application is required, businesses had to procure a new physical server. There is only one production app running on the server, and in most cases, 9 out of 10, the app only uses a fraction of the server capacity, maybe 5 to 10%. What a waste of company money. And you can see how quickly this can become unwieldy and very expensive for the organizations. With virtualization, we are able to squeeze much more from physical servers. This is a bit oversimplified, but the model worked something like the following. On top of the physical server, we have the operating system installed. This is the host operating system, that is, operating system at the physical server level. On top of that, we install a piece of software called Hypervisor. Hypervisor is a technology from VMware that virtualizes the hardware of the physical server. On top of this, we create a virtual machine. In fact, we can create and run multiple virtual machines on a single physical server. My first application runs on VM1 and the second application runs on VM2. If I have a third application, I simply spin up a new VM and then safely and securely run it from the third VM. This is brilliant because we are now able to make proper use of the server hardware. There is no longer a one-to-one mapping between a business application and a physical server. Thanks to virtualization, we can now safely isolate and run more than one application from a given physical server. So every time we need a new application for the business, it is no longer the case where we have to procure a new physical server. With virtualization, we are able to safely and securely run multiple apps on a single physical server. Because of this virtualization, each application thinks it is running on a dedicated physical server with its own dedicated processor, memory, drive space, etc. In reality, they're running on the same physical server but on a dedicated virtual machine. You can think of a virtual machine as a computer within a computer. Multiple virtual machines can run simultaneously on the same physical server. In each virtual machine, we can install an operating system of our choice, Windows, Linux, etc. Typically, we install the operating system and dependencies our production app requires. Virtual machines are great. They allow us to run more than one app on a given physical server, which obviously promotes better use of server hardware. However, with each virtual machine that is created, there is a lot of overhead. We'll discuss what this overhead is and how containers are set out to solve this problem in our next video. This is part 3 of cloud computing tutorial. In this video, we'll discuss what are containers and how are they different from virtual machines. In our previous video, we discussed what are virtual machines and how they allow us to run multiple applications on a single physical server. However, with each virtual machine that we create, there is a lot of overhead, both in terms of cost and maintainability. Let's understand this with an example. Let's say we have 4 applications, app 1 to app 4. We want to be able to run all these 4 apps on one physical server, server 1. Obviously, we cannot run applications directly on the server hardware. We need an operating system like Windows or Linux. This is the host operating system, that is the operating system at the server level. On top of this, we install a piece of software called hypervisor. It is this hypervisor that creates and manages virtual machines. We have 4 apps that we want to run in isolation on this single physical server. So we create 4 virtual machines. As we discussed in our previous video, a virtual machine virtualizes the hardware of the physical server. This means each virtual machine that is created gets a slice of the server hardware. In our case, we created 4 virtual machines. So each VM gets 25% of memory, disk space, processor, and other server hardware resources. Now, our business applications, that is app 1 to app 4, cannot directly run on a virtual machine. Keep in mind, a virtual machine virtualizes the server hardware. This means, in simple terms, a virtual machine is a slice of the underlying server hardware, and an application cannot run directly on the hardware. So, for a virtual machine to be able to run a software application, it needs a full copy of its own operating system. In our case, we have 4 virtual machines. So this means we need to install 4 operating systems, one on each virtual machine, usually Windows or Linux. This operating system that is installed on a virtual machine is usually called guest operating system. So on top of this guest operating system, on the VM, we install our business application and any dependencies it might need. Now, just imagine the server resources that are required to install and run 4 operating systems. So much of server resources like disk space, memory, and processor time are wasted just to keep these VMs up and running. In addition to the wasted server resources, each installation of the operating system also needs admin time. For example, if there is an update or a security patch available for the operating system, the admin needs to download and install it on all the affected VMs. In addition to this, we also have to pay for 4 operating system licenses. Remember, a virtual machine is like a computer within a computer. It has its own operating system. So, for a virtual machine to be up and running, its operating system must also be booted up. Booting up an entire operating system obviously consumes a lot of time. In our example, if we want app 1 to be up and running, VM1 operating system must be booted up. in addition to booting up the host operating system, that is, the operating system at the physical server level. Now, let's understand what containers are and how they are set out to solve these issues. We have a side-by-side comparison here. Remember, a virtual machine virtualizes the server hardware, whereas containers virtualizes the operating system. That is, it's an abstraction at the operating system level. Multiple containers can run on the same machine, and more importantly, they can share the host operating system kernel. Unlike a virtual machine, a container does not require its own operating system. So straight away, you can say the amount of disk space, RAM, processor time, and other server resources that are saved. Each container packages your application code and its dependencies together. If you have 3 apps to run on a single physical server, you create 3 containers. Each application thinks it is running on a dedicated operating system and a dedicated server hardware, but in reality, all the container applications are sharing the same host operating system and hardware. In case of virtual machines, admin time is required to install security patches and keep up to date host operating system and the guest operating systems on all the VMs. In case of containers, no matter how many containers we have on our server, there is just one host operating system that demands admin time. From the cost standpoint, in case of VMs, we have to pay for host and the guest operating systems of all the VMs, whereas in case of containers, we have to pay just for one host operating system. A container is very small compared to a virtual machine. Since a container does not have its own operating system to boot up, it can usually be brought online in a very less time compared to booting up an entire virtual machine and its operating system. We'll see virtual machines and containers in action in our upcoming videos. This is part 5 of cloud computing tutorial. These days, cloud is everywhere. So in this video, we'll understand why cloud, what are the benefits it offers. One of the main benefits of moving to cloud is reduced IT costs. If I have a business application and want to make it available online for users, prior to cloud computing came into existence, organizations had to procure a physical server and all the related infrastructure to host the applications. Servers are expensive, and there you go. Organizations are faced with a large initial capex, that is capital expenditure. It does not stop there. We need a server room, and that needs to be secured. Set up and configure the server, connect it to UPS and network, make sure proper cooling system is in place, install the server operating system, antivirus software, database server, and any other dependencies your business application might have, like .NET Framework, a web server like IIS, for example. All this is the initial setup. It does not stop here either. We need to keep these servers up and running, that is, maintain them in good health. If there is an update or a security patch available, that needs to be downloaded and installed. If there is a hardware failure, power failure, natural disaster, or some other crisis, again, we are responsible for replacing that failed hardware. What about database backups, disaster recovery, failover systems? The list goes on. We need specialized IT workforce both for the initial setup and ongoing maintenance thereon. So the point that I'm trying to make is organizations are faced with a huge OPEX, that is operating expenses, which are every month usually. Moving to cloud reduces both CapEx and OPEX. Organizations no longer have to spend huge amounts of money on physical servers, related IT infrastructure, specialized IT workforce, server rooms, or data centers. We introduce the cloud infrastructure and pay a monthly fee for the resources and services we use. With cloud, it's pay as you go, meaning you only pay for what you use. It's like your utility bills, electricity or water bill, for example. If there's a lot of demand for your application and you use a lot of cloud resources like storage, computing power, etc., you pay more. You use them less, you pay less. So the bottom line is cloud resources are metered and you only pay for what you use. Cloud provides a lot of scalability and flexibility options. Maybe you're launching a new business or product line and you need more cloud resources. You can scale up cloud resources like memory, processing power, storage, etc. with just a click of a button. You can even automate this by setting threshold limits. For example, if 90% of the existing storage capacity is reached, add another 100 gigabytes to the storage. You can do the opposite as well. If you're not using the resources, you can scale them down. Again, even for scaling down, you can set the threshold limits and automate. With cloud, we will never run out of resources. When you need more power, scale up. And when you don't, scale down. You no longer have the burden of purchasing and installing that expensive upgrades yourself. Your cloud service provider like Azure or Amazon Web Services, for example, handles this for you. Cloud-based applications, services, and data can be accessed from virtually anywhere and anytime. Home, office, while on holiday, or in commute. All you really need is an internet-connected device. Cloud ensures business continuity. If you have your data stored on your own on-premise server, and if there is a hardware failure, power failure, or any other crisis, your data is gone. Without data, it is extremely difficult to run a business. The fact is, no data, no business. On the other hand, if you have data stored in the cloud, hardware failure, power failure, natural disaster, or any other crisis do not result in data loss. This is because in the cloud, data is backed up across the networked servers. Cloud ensures automatic updates. If you have your services and applications on-premise, you are responsible for downloading and installing software updates and security patches, which is not only tedious but also time-consuming. On the other hand, if you're using cloud, security patches and updates are automatically installed off-site by the service provider. You just have to pay a small monthly fee. You don't have to worry about rolling out those updates and patches yourself. Instead, you can use the time to focus on what matters to the business. Cloud increases collaboration. With cloud, it's very easy for teams and team members to access, edit, and share files anytime and from anywhere. There is no longer the need to send documents or spreadsheets in email. It's all in the cloud, and everyone who wants to have access has access. So teams are able to better collaborate and work together. Self-service is another great benefit. Most of the resources and services cloud provide can be self-serviced, meaning with a little bit of learning curve, most people can easily procure, configure, and use cloud resources and services. For example, if you need a server to host your business application, there is no need to consult IT experts to determine how big and fast the server has to be. With just a few simple clicks, you can very easily procure a virtual machine from the cloud and host your application. If you need more processing power, you can scale up. And if you don't need as much, you scale down. Again, with a few simple clicks. You'll see how easy it is to create VMs, containers, scale resources up and down, etc. in our upcoming videos. This is part 6 of cloud computing tutorial. Moving to the cloud is a great step forward. In our previous video, we discussed benefits of cloud computing. In this video, we'll discuss risks of cloud computing. Loss of cloud data and services is one of the main risks. Data in the cloud and services are typically accessed over the internet. So this obviously means the speed at which you can access cloud services and data are limited by the speed of your internet connection. If your connection to the internet is lost, your access to cloud data and services is also lost. The servers or network at the cloud service provider end can also go down for a number of reasons. Again, when this happens, you lose access to cloud data and services. However, the good news is cloud service providers have SLAs, that is, service level agreements. Most of the cloud providers guarantee 99.9% uptime. If they fail to meet this service level agreement, you will be compensated. Data security. When you store your business, employees, and customer data in the cloud, you're placing your complete trust on the cloud service provider to secure and safeguard your data. Cloud service providers like Microsoft Azure and Amazon Web Services invest lots of resources and money to implement and improve cloud security. But still, by placing your data in the cloud as opposed to in-house, you're opening up security risks. Also, everyone, including hackers, know if they can manage to hack into cloud service providers, they will have access to huge amounts of data. So as we speak, there are hundreds of thousands of cyber attacks going on around the world. Take a look at this Bitdefender webpage. You can see the real-time cyber threat map. Every second, in fact, every few milliseconds, there is an attempted cyber attack. You can see the time, attack type, attack country, and the target country. So the point that I'm trying to make is, by placing your data in the cloud, you're relying on the cloud service provider to protect your data. And the fact is, your data is only as secure as your cloud service provider. However, best practices like encryption, two-factor authentication, auditing, reviewing and rotating access keys and credentials can reduce the security risk to some extent. Compliance is another important risk that must be considered when moving to cloud. If it's your own personal data, like emails or photos for example, you don't have to worry about compliance and legal risks. However, if it's an organization and if it deals with financial data, healthcare data, credit card data, or any regulated data for that matter, by law, the organization is responsible for protecting that data. It also needs to know where the data is stored, who is allowed to access it, and the measures that are put in place to protect it. There are many local and international regulations like GDPR, HIPAA, etc. By moving to the cloud, you're relying on the cloud service provider to protect data and adhere to these local and international regulations. Your company may still be liable if the cloud service provider fails to live up to the task and if there is a data breach. Cloud, in general, reduces upfront infrastructure costs, and its pay-as-you-go model provides more flexibility. Depending on the traffic, the amount of cloud resources you consume, the plan you have chosen, the way you scale resources up and down determines the overall price you pay. Sometimes this overall price tag may be higher than what you have anticipated. Most cloud service providers like Amazon Web Services, Microsoft Azure, Google Cloud Platform provide cost calculators, and it's a good idea to use these calculators to get an estimate of what you will be paying. You may also experiment different options and plans until you find what works best for you. There are several things that you can do to reduce your cloud costs. For example, try not to over-provision cloud resources. If you think performance will be an issue, you can always auto-scale up resources based on certain pre-configured threshold limits. And don't forget to auto-scale down as well. Otherwise, you'll end up paying for resources that are not being used. Along the same lines, automate the process to start or stop your server instances. This ensures you're not paying when you're not using them. You can also create alerts that notify cloud spending. It's always good to keep these risks in mind before moving to the cloud. The good news is there are different types of clouds, best practices, and proven techniques that can mitigate some of these risks. We'll see all of these in action in our upcoming videos. This is part 7 of cloud computing tutorial. There are different types of clouds: public cloud, private cloud, hybrid cloud. In this video, we'll discuss what is a public cloud, its benefits, limitations, and use cases. In our upcoming videos, we'll discuss private and hybrid clouds. First, public cloud. As the name implies, a public cloud is public, and it is the most common type of cloud. It is easy for anyone, that is, an individual or an organization, to start using public cloud resources and services. There is no upfront huge capital expenditure. You don't have to buy the expensive hardware or worry about setup and maintaining the cloud. This is because with the public cloud, all the infrastructure, that is, the physical servers, storage, networking, etc., are procured and owned by the cloud service provider. It is this cloud service provider that sets up the cloud and maintains it thereon. Microsoft Azure and Amazon Web Services are examples of a public cloud. We access public cloud resources and services over the internet. So to use a public cloud, we need an internet connection. And to manage the cloud services and resources, the cloud service provider provides a web portal. For the cloud services and resources we use, we pay a monthly fee to the cloud service provider. This monthly fee is like your utility bills, water or electricity, for example. It's pay-as-you-go model, meaning you only pay for what you use. Anyone can use the public cloud. In a public cloud, your organization share the same hardware, storage, and network devices with other organizations. In cloud computing terms, this is called multi-tenancy. Your organization data may be stored along with other organizations' data on the same storage device. Now, let's look at the benefits of the public cloud. You don't have to buy expensive hardware or set up your own data center. That is, no upfront capital expenditure. It supports pay-as-you-go model. You only pay for what you use, just like your water or electricity monthly bills. No maintenance headaches. You as a consumer don't have to worry about maintaining the public cloud, that is, replacing the failed hardware, installing the security patches, updates, etc. Your service provider is responsible for maintaining the public cloud. You only pay a small monthly fee based on the cloud services you use. Highly scalable. You will almost never run out of resources in a public cloud. Based on your business needs, you can scale resources up and down. You can even automate this by setting threshold limits. Highly reliable. A public cloud is a vast network of servers, so data is always backed up. This means hardware failure, power failure, natural disaster, or other crises do not result in data loss. So, bottom line, public cloud is highly reliable. Next, limitations. Low visibility and control. Public cloud infrastructure is owned by the cloud service provider, so you don't have much visibility and control over it. Compliance and legal risks. Since you don't have much visibility and control over the public cloud infrastructure, you are relying on the cloud service provider to protect data and adhere to local and international regulations. Your company may still be liable if the cloud service provider fails to live up to the task and if there is a data breach. So, a public cloud may not be the most viable solution for security sensitive or mission critical applications. Cost concerns. Cloud, in general, reduces upfront infrastructure costs, and its pay-as-you-go model provides more flexibility. Depending on the traffic, the amount of cloud resources you consume, the plan you have chosen, the way you scale resources up and down determines the overall price you pay. Sometimes this overall price tag may be higher than what you anticipated. Next, let's look at the use cases for public cloud. We never run out of resources in a public cloud. It provides near unlimited scalability. So, if you want to dynamically scale up and down at will, then public cloud is your solution. Businesses with varying peak demands greatly benefit from the public cloud. When there is high demand, you scale up, and when the demand subsides, you scale down and pay only for what you use. Fast growing businesses also greatly benefit from the public cloud. They can use the public cloud and quickly scale up their operations rather than having to build their own private cloud, which not only has huge upfront capital expenditure but also time consuming. Businesses can also benefit from the public cloud by using it for backup and disaster recovery solutions. In our upcoming videos, we'll discuss private and hybrid clouds. This is part 8 of cloud computing tutorial. In our previous video, we discussed what is a public cloud. In this video, we'll discuss what is a private cloud, benefits, limitations, and use cases. And in our next video, we'll discuss what is a hybrid cloud. As the name implies, a private cloud is private to one organization. In other words, a private cloud resources and services are used exclusively by one business or organization. Unlike public cloud, a private cloud resources are not shared by multiple organizations. All the hardware infrastructure and software are solely dedicated to one organization. The private cloud is physically located on premise, that is, at your organization's on site data center, or it can also be hosted by a third party service provider. The important point to keep in mind is a private cloud is private, that is, all the hardware infrastructure and software are solely dedicated to one and only one organization. In a private cloud, it's very easy to customize the hardware and software to meet your organization's specific IT requirements. This is because your organization owns everything, that is, the hardware, software, and network. So you have complete control and can change anything in any way you want to meet your organization requirements. In general, private clouds are often used by government agencies, financial institutions, and any other medium to large sized organizations with business critical operations that want to have enhanced and complete control over their cloud environment. Now, let's look at the benefits of a private cloud. Better security. Resources are not shared with other organizations, so there is better security with private cloud. Better control. A private cloud belongs to a specific organization, so you can customize it to meet your specific business needs. Predictable costs. With private cloud, you own all the cloud infrastructure and you're not paying any third party cloud service provider. So your monthly cooling, energy, and maintenance costs are usually predictable. Legal compliance. When you deal with regulated data, for example, financial, healthcare, or credit card data, there are strict rules around where the data is stored, who can handle and process it, and how it is protected. With the private cloud, you know where your data center is located, so you know where the data is stored and how exactly it is protected. Next, let's look at the limitations. With private cloud, we have limited scalability. The extent to which you can scale up in a private cloud is limited by the amount of infrastructure you have. Beyond certain point, you cannot scale up. So the infrastructure is a limiting factor and you may not be able to scale up at will like in the public cloud. Huge initial capital expenditure. With the private cloud, you have to procure all the cloud infrastructure, hire the workforce to set up and maintain the cloud. So a private cloud is an expensive solution compared to public cloud alternatives, especially for short-term projects. Limited access. A private cloud is usually more secure. We use it for security-sensitive applications. Because of these high security measures in place, mobile users may have limited access to the private cloud outside of the corporate network. When to use a private cloud? Well, a private cloud is best suited for highly regulated businesses like financial and healthcare institutions. Tech companies that require robust security and complete control over the cloud infrastructure also benefit from the private cloud. Large organizations that require advanced and custom data center solutions also benefit from private cloud. In our next video, we'll discuss hybrid cloud. This is part 9 of cloud computing tutorial. In our previous two videos, we discussed public and private clouds. In this video, we'll discuss what is a hybrid cloud, benefits, limitations, and use cases. As the name implies, a hybrid cloud is hybrid. That is, it's a combination of both the private cloud and the public cloud. It's not a different cloud altogether, it's just that both the private cloud and public cloud work together to meet our organization requirements. I mean, it offers the best of both the worlds. For example, we can use the private cloud for security sensitive business critical operations like financial reporting and the public cloud for high volume, low security needs such as web-based email. In a hybrid cloud, we have a concept called cloud bursting. This sounds like a fancy technical term, but all it means is the following. Let's say you have an application or a service. To start with, it's hosted and running in your own private cloud. The application continues to run in your private cloud until there is a spike in the demand. When there is a spike in demand, burst through to the public cloud to tap into the additional computing resources provided by the public cloud. When the spike in demand subsides, you scale down just to your private cloud and no longer use the public cloud resources. Now, if you're wondering, why will there be a sudden spike in demand? Well, there are a number of reasons. Maybe you're launching a new business or product line. Seasonal events like online Christmas shopping or tax filing, for example, may also increase the traffic and hence the spike in demand to your application or service. With private cloud, you only have so much physical infrastructure. How much you can scale up depends on that physical infrastructure. Beyond certain point, if you want to scale up, you have to buy additional hardware, and this is not only expensive but also time consuming to procure and set up. And then when the spike in demand subsides, we are no longer using this additional infrastructure. Now, let's look at the benefits of hybrid cloud. The obvious benefit is a hybrid cloud provides best of both the worlds, that is private and public clouds. Better control. With the hybrid cloud, you have better control on what runs where. For example, you can use the private cloud for security sensitive applications and the public cloud for those applications that have high volumes of traffic but not that security sensitive. Cost effective. With the hybrid cloud, you only use public cloud resources when you need them. That is, when there is a sudden spike in demand, you burst through to the public cloud to use that additional computing power provided by the public cloud. When the demand subsides, you scale down just to your private cloud. Next, let's look at the limitations of hybrid cloud. Low visibility and control. Just like a public cloud, even in a hybrid cloud, you don't have much visibility and control over the infrastructure that is owned by the public cloud service provider. Additional complexity. Integrating private cloud with public cloud introduces additional infrastructure complexity. Also, it involves considerable effort, time, and complexity to maintain and evolve these two different types of clouds as the organization needs change. Compliance and legal risks. Since you don't have much visibility and control over the public cloud infrastructure, you're relying on the public cloud service provider to protect data and adhere to local and international regulations. Your company may still be liable if the public cloud service provider fails to live up to the task and if there is a data breach. Cost concerns. If you use the public cloud resources for a very long time, the overall price tag may be higher than what you have anticipated. Next, use cases. Hybrid cloud provides best of both the worlds, that is, private and public clouds. For example, you are an IT company and provide services to two different sets of clients. For one set of clients, security is not a massive concern. They just want to scale up and down at will. For this set of clients, you can use the public cloud resources. For the other set of clients, security is the most important thing and they want to have complete and rigorous control over the cloud infrastructure. For this set of clients, you can use the private cloud resources. So the point that I'm trying to make is a hybrid cloud allows you to switch between different delivery models depending on your client's security and scalability requirements. This is part 10 of cloud computing tutorial. There are different types of clouds: private, public, and hybrid. In our previous three videos, we discussed what these different clouds are, their benefits, limitations, and use cases. In this video, we'll compare them side by side. First, let's talk about cloud hardware. As far as the private cloud is concerned, the entire cloud infrastructure, that is, the physical servers, storage, networking, etc., must be procured by the organization that owns the private cloud. When it comes to the public cloud service provider like Amazon or Microsoft provides the infrastructure. Now, remember, a hybrid cloud is not a different cloud altogether. It's just that both the clouds, that is private and public clouds, work together to meet the organization needs. So, for the private cloud, your organization must provide the infrastructure, whereas the public service provider provides the infrastructure for the public cloud. Tenancy. A private cloud is usually used by a single organization, that is, single tenancy. A public cloud is used by multiple organizations, that is, multi tenancy. The private part of the hybrid cloud is used by a single organization, whereas the public part of the hybrid cloud is used by multiple organizations. Data center location. Inside the organization's corporate network, anywhere on the internet, public cloud like AWS and Azure data centers, for example, are typically located in many countries across the entire world. The private cloud data center is typically inside the organization's corporate network, and the public cloud data center could be anywhere on the internet. Scalability. Private cloud scalability is limited by the amount of infrastructure. Beyond certain point, it is impossible to scale up unless the organization procures additional hardware and set it up. We never run out of resources in a public cloud. It provides near unlimited scalability. The scalability of the private cloud services and resources is limited by the underlying available infrastructure, whereas with the public cloud services, we do not have such a limitation. Cloud maintenance. The organization itself is responsible for setting up and maintaining the private cloud. The cloud service provider is responsible for setting up and maintaining the public cloud. Organizations and even general public can use the public cloud services by just paying a monthly fee. The private cloud is managed by the organization that owns it, whereas the public cloud is managed by the cloud service provider. Costs. Private cloud involves huge initial capital expenditure as the organization must purchase all the cloud hardware, set it up, and maintain thereon. To maintain the private cloud, the organization needs to hire workforce, so there is monthly operating expenditure as well. With the public cloud, there is no initial capital expenditure, but you pay a monthly fee for the public cloud services you use. The more you use the services, the more you have to pay. The overall price tag may be higher than what you anticipated, especially if you use a lot of public cloud services for a long time. With the private cloud, the organization is faced with both the initial capital expenditure as well as monthly operating expenses to maintain it. With the public cloud, you pay a monthly fee for the services and resources you use. Finally, accessibility. Only the organization that owns the private cloud can access private cloud resources and services. A public cloud is exposed to the public, so anyone can access its resources and services. Private cloud services can be accessed only by the organization that owns it, whereas public cloud services can be accessed by anyone. This is part 11 of cloud computing tutorial. In this video, we'll understand what is infrastructure as a service, also called IaaS. In addition to infrastructure as a service, we also have platform as a service, PaaS, and software as a service, SaaS. Up until recently, these are the three main cloud services offered by most cloud service providers. With cloud technologies advancing and maturing so fast, in addition to these three cloud offerings, we also have containers as a service, CaaS, and functions as a service, FaaS, or this is also called serverless computing. So, in this video, let's understand what is infrastructure as a service, who uses this service, and the benefits it provides. If we are not using cloud, we manage everything on premise. Basically, our organization is responsible for managing pretty much everything. procuring physical servers, storage, and related hardware, install and set up the network, setting up the server room or data center, make sure there is main power supply, backup power supply, cooling system, etc. are in place. Install and configure virtualization software, operating system, any middleware, or runtime components that your software development or other teams need. Install, configure, and manage your custom or packaged apps and data. So the point is, with on-premise data center, our organization is responsible for managing pretty much everything. Now, what is infrastructure as a service? As the name implies, with infrastructure as a service, you rent or lease IT infrastructure from a cloud service provider like Microsoft Azure, Amazon Web Services, or some other cloud service provider. To understand this better, take a look at this diagram. As the name implies, with infrastructure as a service, the cloud service provider provides the infrastructure over an internet connection or through a virtual private network. We'll discuss what a virtual private network is in our upcoming videos. For now, you can think of it as a dedicated and secure private tunnel between you, that is your organization, and the cloud service provider. So, the important point to keep in mind is there is no need for your organization to procure and manage the infrastructure. It is the cloud service provider that is responsible for procuring physical servers, storage, and related hardware, install and set up the network, make sure there is proper power supply, backup power supply, cooling system, etc. are in place. Pretty much, the cloud service provider is responsible for setting up, securing, and managing the cloud data center. So, in simple terms, this is how it works. The cloud service provider hosts the infrastructure at their data center. You, as a customer, provision this infrastructure on demand over the internet or through a virtual private connection. For the duration that you use the infrastructure, you pay a fee, and you're only charged based on the number of machines and resources that are actually being used. As you can see from the image, all the yellow boxes, that is, networking, storage, servers, and virtualization, are managed by the cloud service provider. The rest, that is, the operating system, middleware, runtime, data, and applications, are still managed by you, that is, your organization. This means you have better control and you can install any operating system of your choice, Windows or Linux, for example. So the point is, you can use this infrastructure for anything you want, computational or storage needs. Maybe you have a web application which you can host and run, for example. You can also use it for storage needs. For example, install SQL Server, Oracle, or some other relational database and store your relational data. I mean, a diverse set of use cases are supported. Infrastructure as a service is also known as hardware as a service. So, who uses infrastructure as a service? In most organizations, it is the infrastructure team that procures servers and computers, install software, and provide systems to employees, set up and manage networks. So, in most cases, it is usually your infrastructure team that uses infrastructure as a service. Sometimes, even software development teams use this service if they want to have enhanced control over the underlying hardware and network. Now, let's look at the benefits of infrastructure as a service. There is a reduced financial risk for organizations. Let's say, for example, you want to try something new. Maybe you're launching a new business or a product line or experimenting something entirely new. And for that, we need a software application. To host and run this application, we need a physical server, all the related infrastructure, and workforce to set up and maintain. What if our new product launch or experiment fails? We have already spent a fortune to purchase the server and the related infrastructure. On the other hand, with infrastructure as a service, you pay a fee for as long as you use the cloud infrastructure, host your app, and run it from there. If your new product launch or experiment succeeds, well and good. If it doesn't, shut things down and stop paying. Straight away, you can see how organizations can benefit from the reduced financial risk. This encourages businesses and organizations to try new things, experiment, and innovate more. Deployment speed is another great benefit. Just imagine the time it takes to procure physical servers, storage, and the related infrastructure. You need to purchase, get them shipped over, create a server room or data center, secure it, install power supply and cooling systems, set up and configure network. The list goes on. And don't forget, you also need to hire skilled people to do all this. It takes a considerable amount of time to have all these in place, probably days, sometimes even months in worst case scenarios. On the other hand, if you're using infrastructure as a service, you just point your browser to the cloud service provider web portal, and with a few clicks, in just a few minutes, you have one or even many virtual machines procured. So you can see the speed with which we can procure and start using cloud infrastructure. So you really get time to focus on what matters to your business. Provision resources from geographically closer locations. Cloud service providers, for example, Amazon, Microsoft, and Google, have data centers all over the world. This means with infrastructure as a service, you have the option of provisioning the servers from geographic locations that are close to your customers. Unlimited scalability. You almost will never run out of resources in a public cloud. It provides near unlimited scalability. You can even set threshold limits to automatically scale up and down depending on the demand. In our next video, we'll understand what is platform as a service. This is part 12 of cloud computing tutorial. In our previous video, we understood what is infrastructure as a service. In this video, we'll understand what is platform as a service, also called PaaS, who uses this service, and the benefits it provides. Now, if you watched our previous video, what is infrastructure as a service, then understanding what is platform as a service is very easy. It boils down to what we, that is our organization, manages versus what the cloud service provider manages. With the infrastructure as a service, the cloud service provider manages the infrastructure, that is networking, servers, storage, and virtualization. We manage everything else, that is the operating system, middleware, runtime, data, and applications. When compared with infrastructure as a service, platform as a service provides an even higher level of abstraction. You can think of it as a layer on top of infrastructure as a service. It shifts more responsibility to the cloud service provider. As you can see from the diagram, you manage just your business applications or services and the underlying data. The rest is managed by the cloud service provider. So you don't have to worry about any of the things like managing the network or underlying infrastructure, installing the operating system updates, critical patches, runtime, or middleware components. All these are taken care by the cloud service provider. So this gives you even more time to concentrate on what matters to your business. Who uses platform as a service? Well, it is primarily used by software development teams. As the name implies, it provides the platform for developing software applications. It's a complete development and deployment environment in the cloud. It enables you to deliver everything from simple cloud-based apps to sophisticated enterprise-class cloud-enabled apps. For example, let's say you want to develop a data-driven web application. For this, we need a framework like ASP.NET Core or Java. To store data, we need a database like SQL Server or Oracle, for example. We also need a web server to host and run our web application. Purchasing all these softwares, installing, setting up the development environment, and maintaining it is not only expensive but also time consuming. With platform as a service, the cloud service provider provides all these softwares, installs, and configures them. You have the development platform available with a few clicks in just a few minutes. You pay for the service on a pay-as-you-go basis and access it over a secure internet connection. When you no longer need the service, you shut things down and stop paying. Windows, Azure, AWS, Elastic Beanstalk, and Google App Engine are a few examples of platform as a service. Now, what are the advantages? Well, platform as a service is a layer on top of infrastructure as a service. So it has all the benefits of infrastructure as a service plus the benefits specific to platform as a service. Infrastructure as a service provides many benefits like reduced financial risk, deployment speed, provision resources from geographically closer locations, auto scaling resources, that is, the underlying virtual infrastructure, up and down depending on demand. We discussed infrastructure as a service benefits in detail in our previous video. So now let's look at the benefits specific to platform as a service. It greatly reduces development time. Just imagine the amount of time it takes to procure your own infrastructure, purchase all the softwares, install, configure, and set up your own development environment. With platform as a service, in just a few minutes, with a few simple clicks, you gain instant access to a complete software development environment. It also provides templates and reusable application components and features such as search, directory services, security features, and so on. Platform as a service supports global teams. To access the development environment, all you need is an internet connection. So your development team members can be located anywhere in the world. In any remote location. It doesn't really matter. As long as they have an internet connection, they can connect and work together on projects. Platform as a service provides options for developing multiple platforms such as computers, mobile devices, and browsers. In short, it makes developing cross-platform apps quicker and easier. Affordability is another great benefit. Cloud supports pay-as-you-go model. So with that, organizations of all sizes, including small organizations and even individuals, are able to use sophisticated development software, business intelligence, and analytical tools that they could not afford to purchase outright. So with a pay-as-you-go model, you simply pay a monthly fee for as long as you want to use them. In our next video, we'll discuss software as a service. This is part 13 of Cloud Computing tutorial. In this video, we'll discuss what is software as a service, who uses this service, few examples, and the benefits it provides. Now, in our previous two videos, we discussed infrastructure as a service and platform as a service. In this video, we'll discuss software as a service. As you can see from the diagram here, with software as a service, the cloud service provider manages everything for us. We don't have to worry about anything like purchasing and setting up physical hardware, installing operating system, virtualization, setting up network, installing and maintaining middleware, runtime, and applications. All these are taken care by the service provider. So the bottom line is all the hardware and software is maintained for us by the cloud service provider. We simply access the software, that is the application which we want to use for our business, over the internet. The software runs at the cloud service provider data center on their physical servers. Even the data the application captures is stored at the cloud service provider data center. So the point that I'm trying to make is everything is managed for us by the cloud service provider. We simply access the service over the internet, and as it supports pay-as-you-go model, we pay a monthly fee based on the usage. Who uses software as a service? Well, everyone. Individuals and organizations of all sizes, small, medium, and even large enterprises. I bet most of us will be using at least 2 to 3 software as a service applications. A few examples of software as a service applications are Gmail, Netflix, Amazon Prime, Dropbox, Google Drive, and Office 365. How many of these SaaS applications do you use? If you ask me, I use all of them. If we take Gmail, for example, it is hosted by Google on their physical servers at their data centers. We don't host or install anything on our computer or laptop. We simply fire up our favorite browser, like Google Chrome, for example, point it to gmail.com, and access the Gmail software as a service over the internet. There are a wide variety of SaaS applications, both for personal and business use cases. We have SaaS applications for customer relationship management, CRM, financial management, sales management, human resource management, HRM, billing, entertainment, storage, collaboration, the list goes on. Now, let's look at the benefits. It's very easy to get started with a SaaS application. Think about a traditional business application running on premise. You need to purchase hardware, that is, a physical server, and all the related hardware. Install the operating system, runtime, middleware, and any other dependencies. On top of this, you install the software application, configure it, and then you have it available for business. You also need to recruit workforce to maintain the servers and the application, that is, to install patches and updates. Now, compare this to a SaaS application. You simply fire up your favorite browser and access the SaaS application over the internet. There might be some customization and configuration required, but it is definitely very easy to get started with a SaaS application than running that same application on premise. Accessibility is another great benefit. You access SaaS applications over the internet. So this means as long as you have an internet connection, you can access a SaaS application from anywhere and any internet enabled device. Automatic updates. With a SaaS application, you don't have to worry about installing updates or patches. These are automatically provided by the cloud service provider, that too, in most cases with a zero downtime. This obviously reduces the burden on the in-house development and IT staff. Flexible, usage-based pricing. No upfront, huge capital expenditure. You only pay for what you use. For example, if you have 10 users using the application, you only pay for that 10 users. You also have the flexibility to scale the number of users up and down depending on your business needs. With SaaS applications, there is reduced financial risk. For example, if you want to see if a SaaS application adds value to your business, you can start with 1 or 2 users and then see if it's really adding any value. If it is, then you have the option to scale up the number of users. If it's not adding any value, you simply stop using the app and the payments. These days, most cloud service providers also offer free trials. You can try a SaaS app for free and see if it's adding any value. If it is not, there is no cost to your business anyway. Compare this to buying an expensive hardware and a packaged app upfront. With SaaS applications, businesses definitely have reduced financial risk. Affordability is another great benefit. Applications and solutions that fall in the category of CRM and ERP, for example, are very expensive. By the way, CRM stands for Customer Relationship Management and ERP for Enterprise Resource Planning. So these softwares are very expensive to buy outright, especially for individuals, small and medium organizations. It's a huge burden. However, SaaS applications' flexible pay-as-you-go model allows even small and medium organizations to trial and experiment if these expensive apps add value to their business. Basically, it levels the playing field for everyone, including small businesses and individuals. This is part 14 of Cloud Computing tutorial. In this video, we'll wrap up this Cloud Computing Basics course. Cloud computing is everywhere. It's a big shift from the traditional way businesses think about IT resources and software solutions. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases. It is the future. Whether you are a software engineer, quality engineer, business analyst, software architect, IT manager, or a CTO, that is Chief Technology Officer, it has got something to offer to everyone. If you don't upgrade yourself and learn cloud computing, sooner or later you are out of the game. In this course, we've covered several important cloud concepts: the state of information technology before virtual machines, what is a virtual machine, what are containers, what is a cloud, and why is it important, different types of clouds like private, public, and hybrid, different types of cloud offerings, infrastructure as a service, platform as a service, and software as a service, benefits and risks of moving to a cloud. Cloud computing offers several benefits, and we discussed them in detail in our previous videos in this series. Just like everything else, along with the benefits, cloud computing also has risks. We must know and consider these risks before moving to a cloud. Again, we discussed the risks of cloud computing in detail in our previous videos in this series. Data security is one of the very important risks you must consider. When you store your business, employees, and customer data in the cloud, you're placing your complete trust on the cloud service provider to secure and safeguard that data. I want to take this opportunity to clarify one potential point of confusion you may have on your mind. If you're thinking your applications and data are more secure in your own data center, you're almost certainly mistaken. Cloud service providers, at least the big reputable players like Microsoft Azure, Amazon Web Services, and Google Cloud, for example, invest lots of resources and money to implement and improve cloud security. They're experts in this area. Their data centers are far more secure than our own data center. So, in reality, by moving to the cloud, you're actually improving security, not reducing it. In addition to this, best practices like encryption, two-factor authentication, auditing, reviewing, and rotating access keys and credentials can reduce the security risk to a great extent. Like everything else, cloud computing has benefits and risks. We are far enough into the cloud revolution, it has matured so much that these risks have been dealt with in many ways. Cloud is here to stay, and it has fundamentally changed the way businesses think about IT resources and software solutions. So, this is a wrap of this course. I hope you have enjoyed it as much as I did creating it. You can find all these course videos, slides, and text articles in sequence on our website prejimtech.com at this URL. Your feedback means a lot and is really important. If you have a couple of minutes, please provide your rating and valuable feedback on the reviews tab. Our next course is going to be Azure Tutorial for Beginners. Azure is the cloud computing service from Microsoft. In this course, we'll discuss everything you need to know to build, deploy, and scale applications using Microsoft Azure. If you have a specific concept or topic in mind that you want me to cover as part of this course, please leave it as a comment on this video and I will surely cover it. This is Venkat. Thank you for watching.